Okay, hi to my CSCE1030 gang, and welcome to the recorded lecture for the January 31st Friday classes. And what we're going to do today is we're going to finish up a couple of slides from the presentation we've been working our way through. And then I've got a special treat, especially for those of you who are having trouble with the homework. So here's the last topic, one more sometimes useful command that can be found in stdio.h. This one's called system. And what system allows us to do is to pass a string that represents a command, an operating system command, back to the operating system from within our program, have it execute, do whatever we've asked it to do, which could involve printing something to the screen or whatever, and then return to our program. So this could be any kind of command. It could be something like an ls or a dir, or it could be a rm to delete some files, or whatever it is we might want to do. It could even be running another program. Do realize that the output from anything that you do with a system command does not come back to your program. It's going to stay, it's going to do whatever its normal standard output is to whatever that device is, unless you did a redirect or something. So now we do have to be careful using this command because once we put it into our code, we've made our program platform dependent. So if it's a DOS command, then it can only run on DOS machines. It won't execute properly on a Mac, for example. If it's a Linux command, it'll execute probably on a Mac and certainly on a Linux box, but not elsewhere. So we have to be careful that that we realize that when we choose to put one of these into our code. Let's look at a simple example. It doesn't do anything earth-shattering, but it shows you how this basic concept works. So here is a main, very simple main. It's only got 3 lines of code. It's got a variable declaration that's going to hold the return value for what system does, and then a system call here, which is using a DOS command, dir, which is similar to ls in Linux, and giving it a file called data file. So it's just going to do the listing for this file, showing its permissions and ownership and all that kind of stuff. And it's going to display on the screen wherever we run this program. And then we get a return value back from that. Return value is like the exit code from that program. But instead of it going back to the operating system, it's coming back to our main. And it comes back in a 32-bit value, but it's in the upper part of that 32-bit value. So the shift, which this is using a C command that does a shift, or C instruction, shifting 8 bits to the right. So it shifts that number that's in the upper part of that 32 bits down into the lower part, so it looks like a 1, 2, 3 or whatever. And then we're just returning that as our exit code. We could process it here, which would be more likely to see if it's a 0 or not, because that's usually what we're interested in. But in the simple program, we're just returning it. Understanding that is not as important as just understanding how to use the system call. Again, be careful when you use it, because it does potentially create us a problem if we try to move code from one kind of platform to another. Okay, now what we're going to do is we are going to take a problem definition. I'm going to open up a Word file here. Make it a little bit, well, that's fine. And what we're going to do is, I've written a problem definition similar to the one for your homework, although abbreviated. So I'm going to show it to you. And what we're going to do here, the task here is that we're supposed to write some code for a company called Easy Gas that delivers gasoline to rural and commercial customers that have their own tanks. And we're going to compute basically, for a given customer's tank, how many gallons do we need to bring to fill up their tank, assuming it's empty, or like a new tank. So the tanks are cylinders. That makes it nice and easy because we know the geometry and stuff for cylinders. We know for a given customer what the diameter of the cylinder is and what its height is. And from that we can compute its volume, because we know the volume of a cylinder is, first of all, the area of the circle, which is pi r squared, and then times the height. So we know that from our geometry. And then we're given the fact that the conversion that we're going to use from cubic feet, because that's volume, to gallons is 7.48, so 7.4805 gallons per cubic foot. And we want to round up the truckload in gallons to the nearest gallon. So if it's over half a gallon toward the next gallon, we're going to round up. So traditional rounding like we think of. Similar to the problem you're going to do in homework, you have to gather a few more pieces of information. You still have to compute a volume, but yours is rectangular, so pi is not involved. You do have to do rounding, but your rounding is a little different because you want to always round up to the next integer, even if it's not over a half. So in your case, if it was 10.01, you still want it to be 11. But if it's 10.95, you also want it to be 11. So your computation is going to be a little bit different, but it's going to follow the same philosophy. So the first thing we need to figure out is what kind of data do we need? Okay, so from the user, we're going to need two pieces of data. We're going to need a diameter, which is a float, and we're going to need a height, which is also a float. And then internally, we're going to need a radius, which is a float. We're going to need a volume, which is a float. And we're going to need a gallons computation, which is a float. And then when we display the final result, we're going to truncate it to an integer. So we have a whole number of gallons. Okay? So let's think about doing a design. So what are the steps involved in solving this problem? Well, the first thing we have to do is we have to retrieve some information. So we have to get the diameter. In that case, it's going to be from the user. We have to get the height. Right? Then we have to compute radius. I should say compute, not computer. Autocorrect helping me there. And then we have to compute the volume. And then we have to compute the gallons. And then we have to display the result. And your steps will be similar. There's just some more things you have to retrieve. Okay? And that's it. That's all our steps. Okay? Now, if I'm going to do this on the CSE machines, for example, from my Mac, I'm going to need to open a terminal window. If you're on a Windows machine, you'd use PuTTY for this. So here's my terminal window that's currently just on my local machine. If I want to access one of the CSE machines, if PuTTY, you would have a profile set up to do that. Here I just do an SSH, and then my EUID number, and then an @sign, and then the machine I want to log on to. And we'll just use csce01 for this purpose, but it could be any of them. .csc.unt.edu. So my SSH, my EUID, and then the address, the URL, if you will, of that machine. That's going to log me on, and then I need a password. So I'll log on with my password, and that's logged me on. I'm going to move to a directory I've set up for this class, and now we need to create a C file. I'm going to make this window a little longer so we can see a little bit more. I'm going to do it clear just to get it back at the top. And so I'm going to use the Joe editor, and we're going to create a file called easygas.c. Okay. And so the first thing I'm going to do is put in my comment block with, this is homework 1 for csce1030. And you'll follow the instructions on the homework write-up of exactly what this header should look like, but I'm just giving you an idea. And it's my program, and that's it. So I'd have that first. Then I need stdio.h. I forgot the, there we go. And then I need main. And we'll say main's going to return an int. And then I need some curly brackets, and I'll go ahead and put both of them in there, and then we'll do the work inside. So the first thing I need to do, of course, is declare my variables. So we said we needed a float. We need one for the diameter, one for the radius, one for the volume, one for the gallons, and for that diameter and the height, HT. So there's my variables. And then the first step then is I need to get the diameter. So I'm going to put a comment in that says get diameter. In other words, I'm going to use my design as comments for my code. So I'm going to say printf enter diameter of tank to 2 decimal places. Colon space. And of course, I'm not going to put a new line because I want it to stay on that line. And then I'll do a scanf of a %f and put that into the diameter value. And then I need to get the height. So similarly, printf enter tank height. With 2 decimal places. Got a quote up here. So let's fix that. That's why the colors don't look right. Right there. Okay, that looks better. Oops. Okay, and then I need a scanf of another %f, %f, and that's the height, ht. Okay, so I've got the read in the 2 values that I need. So now I need to compute radius. That one's pretty easy. Radius equals the diameter divided by 2.0. And then I need to compute the volume. And we know that is, we called it vol, and that's equal to pi. So we'll just use 3.1415 times, and then we need the radius squared. We'll just do r times r times the height. There's my volume computation, and then I need to compute the gallons. Compute gallons. And so that we call that gal, and that's the conversion factor 7.4805 times the volume. And I'm going to put all that in parentheses. And then once we have that, we'll add 0.5 to do the rounding for us. Again, your homework will be a different number there, but same basic concept. Now I can display the results. And here I'm just going to use a printf, and I'm going to say the tank load required is, and then I'm going to print it out as an integer. So I'm going to use a %d, and then I'm going to say \n. And then here what I'm going to do is I'm going to typecast. So I'm going to say int. I'm going to typecast the gallons to an int, so it'll truncate and just give me a whole number. Okay. And then I can return. Okay, I'm going to save that. And so now that's saved. So let's try compiling. CC, And I'm going to call my output file EasyGas. And then I need to tell it the name of the input file, which is easygas.c. Oops, I have a syntax error. Now I did that intentionally, so we'd have one. Some of you may have noticed that. So I need to go back into my editor. So I'll say Joe easygas.c. And it tells me that it's right before a curly bracket, the closing curly bracket. There's only one of those in my program. It says it's line 38. And when I go back into Joe, it puts me right about there. This is actually row 37. I can see the counter at the top. So this is row 38, but there's nothing wrong with the closing curly bracket, but you'll notice I left my semicolon off, which is what it told me. I left my semicolon off right there. So we'll put that in, and then save it again. And then we'll do our CC again, cc-o easygas, and then easygas.c. Compile it, looks good. So I'll say /easygas. And sure enough, it asked me for my diameter. So I'm going to say 10, which means the radius would be 5. I'm going to say the tank height is 10. This is just so we can compute it in our heads. So if my height is 10 and the radius is 5, so 5 squared is 25 times 10 is 250 times pi, that's going to be somewhere between 750 and 800. So let's call it 800. And then 800 times 7.4805, which is almost 7.5, that's going to be 7 times 8 is 5,600, and then a little bit more, so let's call it about 5,800. So we should get an answer that's about 5,800. 5,875, pretty close for doing it in our heads. So we can certainly work it out with the calculator and make sure that's an exact right number. And you should do that when you're doing your homework. You should work out 2 or 3 sets of numbers so you know what correct answers are, and then you can use those as test numbers when you run the code like what we just did. So that's basically the set of steps you have to do for your homework, except you also have to write a report. And the report's just going to be a couple of paragraphs saying, you know, the experience you had in doing this, does your program work correctly? If it doesn't work correctly, what's the problem? Is it that it doesn't compile? Is there a computational error? Try and give us an idea that you know what the problem is. Maybe you just didn't have time to fix it. Were there any problems you encountered? Was there something that you didn't understand? Just kind of giving us an overview and a review of what your experience was in doing this particular assignment. Now, if I wanted to do this locally, what I would need is a C compiler locally, and the Mac uses something called Xcode. There's an Xcode developer's kit that you can download for free. You may already have it. If you try to run CC just from the command line locally, right now I'm logged into the CSC machine, but if I do exit and get back to my just local prompt, and I tried to run CC and I don't have Xcode, it'll prompt me to install it. So that's all you need to do the first time. And then I would need to use something like my terminal program to copy it down to my local machine, or I could just edit it here initially with some kind of text editor. And then I could do a CC here. And I've already downloaded it, so I think if I CD to my desktop, oops, I didn't type that right, it's capital D, then I already have it, so I could do cc-o easygas, and then easygas.c, and it compiles, and then I could run it, and I would get a similar, inner diameter, inner tank height, and I get a similar answer. So in order to do this on the Mac, you're going to need to use the terminal program, which is already there. If you want to run locally, you'll need to have the Xcode kit installed. And then to move files back and forth between your local machine and the CSE machines, you'll need something like Transmit, or Yummy is one that several students are using that's free, or some other kind of SCP, FTP type client. If you're on a PC, PuTTY and WinSCP, which you've used in the lab, and then a C compiler like GCC or some other one that you can find for free out doing a Google search, and you can do the work locally. But of course, you can always do all your work on the CSE machines, just like I just did, and then you know all the tools are there, and you also know those are the tools we're going to test your code with. So hopefully that'll help some of you that are struggling a little bit on what to do on the homework. You certainly have your peer mentors available for the rest of the week. If you have lab this week, still and you haven't gone to lab yet, your lab TAs can help you as well. You're certainly free to email me. I'll get back to you as quickly as I can, although I will be out of pocket some of the day on Thursday and Friday for travel as well as for a funeral. So give it your best shot. Hopefully you've already started by now and you're well past this point, but if not, this may help you a little bit. And good luck on your homework, and I will see you on Monday. Have a good weekend.